Hi, everyone, and welcome back to our series involving online interviews of our main partners from the NEUREKA Consortium, where they get the chance to tell us a little bit about themselves, their expertise, and contributions towards this multinational, multi-institutional project. So what is NEUREKA? Well, NEUREKA is an innovative hybrid technology where nanoelectrodes and sophisticated computational models of neuronal circuits are combined. And this can be used to obtain readouts and manipulate activity and connectivity in cultured neuronal networks modeling Alzheimer's disease. My name is Dr. Pravina Managaran, Senior Scientist here at Maxwell Biosystems, and today I'll be interviewing Professor Marco Fanciulli. He is full professor in the Department of Material Sciences at the University of Milano and is a fellow of American Physics Society. He was also previous leader of the MDM lab in ST Microelectronics in the Italian Institute for Condensed Matter Physics. Welcome, Professor Fanciulli. So I'd like to begin the interview by asking you to give us some details on your background and expertise.
Yeah, I graduated in Italy in nuclear engineering, and then I went to US, to Boston, for my PhD in applied physics. Then I spent 5 years in Denmark working on mainly silicon and semiconductor technologies and science. Then I came back to Italy more than 20 years ago to establish a new laboratory at a government laboratory inside ST Microelectronics dedicated to micro nanoelectronics. And then later I got a position as a full professor at the University of Milano Bicocca in the Department of Material Science. And my main expertise is in material science, spectroscopy technique for micro nanoelectronics, spintronics, and also innovative type of devices for computation and memories.
So what is the main role of your lab in this NEUREKA project?
Yeah, in the NEUREKA project, the main goal of my group is the growth by atomic layer deposition, which is a technique which is providing highly conformal deposition. And since we are supposed to grow on nano pillars, that is absolutely mandatory for this project. And then the characterization, structure, morphology, physicochemical, electrochemical, using different method of thin metallic and or insulating layers suitable for neuroelectronics, in particular, of course, for the stimulation and the recording of the action potential.
So what are the main contributions of the NEUREKA project that will advance your specific field of research?
Well, the project, of course, is allowing and is providing an opportunity to broaden the processes and the materials that we are growing currently with atomic layer deposition. The system that we are using is a new system which was installed in 2021, and with also the plasma, and that is offering new possibilities for the growth. So that is certainly broadening of material is definitely important. New competencies also in the type of characterization that we do. We were used to characterize the material for nanoelectronic application. Now, since we are focusing on neuroelectronic, we have to broaden our experience also on electrochemical characterization of this material, also interacting with other people and educate ourselves to certain type of measurement that were not so familiar for us. Of course, more focusing on the semiconductor standard technology. So that is definitely an important activity which is advancing our specific field of research. And of course, also being a truly interdisciplinary community, establishing link between the material science and neuroscience is also very challenging and also quite intriguing objective.
So how many researchers are involved in their group and what are their expertise?
Yes, in my group, we are dedicated to different research activity, particularly for the neuroelectronic. Besides myself, I have a postdoc working with me, Valerio Di Palma, who is working on the atomic layer deposition and also the characterization, electrochemical, chemical, physical characterization of the thin films. And also PhD student and master student are involved in this activity. In addition, I'm collaborating and I acknowledge the support of the people at MDM Laboratory in Agrate and also ST Microelectronics. And also I'm interacting here inside the department with other colleagues and also with the Department of Physics. So the main expertise of the people involved in this project are related to material science, physical chemical characterization, and also electronic characterization and simulation of the devices.
So NEUREKA is an interdisciplinary project across Europe. Can you elaborate on the impact of the other project partners on your own research?
Yeah, as I already mentioned earlier, definitely this interdisciplinarity is very, very challenging, is intriguing and challenging at the same time. It's difficult, of course, to have a common language, and that is certainly a huge effort that we have. We had other projects along the same line of NEUREKA, and always we had the problem of being able to talk to the different communities, the neuroscientists and the material scientists and the physicists and the electronic engineers. And that is really difficult and challenging things to do. But on the other hand, we have learned a lot from each other. And I think this will also at some point provide new opportunities and a vision which is more unique and unified, let's say, taking into account all these aspects, which can lead to novel ideas and novel, hopefully, devices which can be used in this field of neuroscience.
So the final question for today is, well, do you have any general remarks, or as well, can you tell us a little bit about the project outlook?
Yeah, as I said, within the project, we develop new processes, and we will continue to look for new processes and new materials deposited by atomic layer deposition to be integrated in microelectrode arrays or nano electrode arrays. And definitely we are looking for new opportunities to work together with the partners on new project in the same line. And also with looking for collaboration with the industrial partner active in this field. We had some contact besides the partner already in NEUREKA, of course, but also other industrial partner on possibility to develop or to integrate actually the materials in something that they produce with more standard technologies. So that is the project outlook, definitely. In addition, the working on a project in which there is the neuroscience, the neuroscience aspect is the dominating part. Neuroscience can also get into project in which the new kind of computation can be also considered, and to have, for example, a link between the real neurons and artificial neurons or synapses. That is also an intriguing future objective that certainly we would like to exploit with other people at the European level.
Great. So thank you very much for your time today. And we're very much looking forward to seeing the outlook of your project for the future.
Thank you, Pravina. Thank you very much.
Thank you.
Bye-bye.